Alright, this is part 3 of section 3.4. Now we're talking about the domain of a composite function. Okay, so the domain of a composite function such that f of g is dependent on the domain of g and the domain of f. We're going to look at the domain of g and the domain of the composition after we find it. Okay, so let's assume that we know the domains of g and f separately. If we write the composition for an input x as f of g of x like here, then what we see is that x has got to be a member of g, and then g of x has got to be a member of x. That's what this is saying. Otherwise, if x is not a function of g, we can't find g of x. If g of x is not a function of f, then we can't find f of g of x. Okay, so what we need to do is find the domain of g, and then we'll find the domain of the composition, and we'll put them together. That's basically what this is saying right here. So let's look at this domain right here. Find f of g, so we're putting this function into this one, so I need to find the domain of g of x, which means since it's a fraction, I'm going to set the bottom equal to what we don't want it to be, 0. So that's going to be 2. I'm just solving for x here. So x cannot be equal to 2/3. Now I'm going to put this up here. I'll bring it back later. Now what we're going to do is we're going to find the composition of f of g. So f of g. So it's going to be 5 divided by not x minus 1, but 4 over 3x minus 2 minus 1. And to get rid of that fraction within that fraction, I'm going to multiply the top and the bottom by 3x minus 2. Now this is going to be multiplied by the entire top. This will be multiplied by the entire bottom. So we'll have 5 times 3x minus 2 times 4 over 3x minus 2 times 3x minus 2, and then minus 1 times 3x minus 2. Okay, so we'll have, looks like 15x minus 10. These will cancel, and I'm left with 4 minus, that's going to be 3x plus 2. And let me get rid of some of this up here. Okay, so then we're going to have 15x minus 10 all over, that's going to be negative 3x plus 6. Now this is the composition f of g, this function right here. Now what we need to do is we need to define the domain for this one. So since it's a fraction, all I'm going to do is take the bottom, I'm going to set it equal to the thing I don't want it to be, which is 0, and solve. So negative 3x, negative 6, divide by 3. So x cannot be 2. Okay, so x cannot be 2. So you put those two together, and that would be the domain for the composition function. Now you could also write it as interval notation, so negative infinity up to 2/3, union with 2/3 up to 2, union with 2 up to infinity. So both of these are saying, both of these right here is saying x can be any number that it wants to be except for 2/3 and 2. Now let's look at this one right here. So f of g, we're plugging this function into this one right here. So I need to find the domain of g. Now we have a radical So that means that I need to set what's inside to be greater than or equal to 0 and solve. So x can be greater than or equal to -4, and I will put that up here for now. Bring that back later. And then we're going to find the composition of the function. So f of g be 1 over not x minus 2, but the square root of 4, or sorry, square root of x plus 4 minus 2. Okay, fraction again. So I need x plus 4 minus 2 can't be equal to 2, or 0, sorry. Move that 2 over. Going to square both sides. So x plus 4 cannot be equal to 4. Subtract 4. So x cannot be 0. Okay, so put those two together. X can be greater than or equal to -4, and x cannot be equal to 0. So let's write that up here. Okay, if we're going to write that in interval notation, we can start at 4, but go up to 0, union that with 0 to infinity. So that's saying we can start at 4 and go all the way up to infinity, but we got to skip over 0. So start at -4, go up to 0, skip it, and then all the numbers after 0 will be fine. So this would be the domain for this compositional function. What you do is you find the domain of the function that is being put into another function, then find the composition. After you find the composition, find the domain of the composition. Put those two domains together, and that will be the domain of the compositional function.